So we are continuing with the monopolistic market structure, right? We are talking about a pure monopoly. In the previous lecture, we have seen a numerical example. In case of a monopoly, we talked about also what it means, what are the defining characteristics of a market structure which is referred as pure monopoly, right? So we have one seller and it is producing a product or service without close substitutes, and there are barriers to entry. Now we will see the graphical representation of a firm which acts as a monopoly and what happens in the short run and in the long run. Then, by looking at those graphs, we will make a comparison between these two extreme cases, monopoly and perfectly competitive markets. As I said before, these two extreme cases of market structure are harder to find than the cases which are in the middle, cases of imperfect competition. But by understanding these two extreme cases and by comparing them, it will also be much easier for us to understand in between cases. So now we will work with a graphical example. I will use a very simple linear equation. So I'm giving you an equation that represents the market demand curve in a sector which the firm produces something that is very unique, okay? So the market demand curve So this is a negatively sloped demand curve. The relationship between quantity demanded price is negative, as you see from the slope. If we would like to draw this on a graph, it will be very easy. The slope is constant, -1, right? And let's draw it. When price is 0, right? When price is 0, quantity demanded will be 10. So here, horizontal intercept will be 10. When quantity demanded is 0, price will be 10. This is how we find vertical intercept, right? And this will be my demand curve. Now, let's say this is the demand for a new beverage for which this firm has a license, something like Coca-Cola, but it is the single firm, right? And this is its demand curve. Now we will analyze profit. We will show profit on this graph. Now think about this profit-making perspective. For any firm, the definition of profit, let's go back to that. Total revenue minus total cost, right? And total revenue is price times quantity minus total cost. Now remember, the definition of marginal revenue and marginal cost. For any firm, marginal revenue is the change in total revenue with respect to change in quantity. Marginal cost is the change in total cost with respect to change in quantity. So, like a firm in perfect competition, a firm in a monopolistic situation also compares marginal revenue to marginal cost, okay? So, for this firm as well, we will need marginal revenue and marginal cost. That is what we did in the previous session with numbers. Now, how can we do this on the graph? Our starting point, because this is a monopoly, this demand curve is also the demand curve faced by the firm. So please, when I'm describing this, imagine what we did in perfectly competitive markets. In perfectly competitive markets, market demand curve was different than the demand curve faced by the firm, which was horizontal in that case. Now the market demand curve is the same as the demand curve faced by this firm. So, and I know that demand, right? So I want to find marginal revenue. Marginal revenue is, by definition, change in total revenue divided by change in quantity, okay? So how can I write total revenue equation? I want to write total revenue as a function of quantity here. Total revenue is defined as such, price times quantity. So come back here. Instead of price here, we will write this equation because this is price. Okay? Times, what do I have here? Quantity. Price times quantity. Okay? So total revenue as an equation. Now let's do this. 10 times Q minus Q square. Okay? For any given linear demand curve, it is very easy to find total revenue curve, right? But just be careful. Sometimes demand curves are given in the form of quantity is equal to P 10 minus P. I can write the same equation as quantity is equal to 10 times P. Do not use that equation because here I want to write total revenue as a function of quantity. So first you would like to express the demand curve as a function of quantity, then use that equation here, right? And then write total revenue. This is total revenue, right? What type of shape this total revenue will have, I will not draw, but you can easily see because the total revenue numbers in our previous numerical example also correspond to such an equation. So if you go back to our numerical example, right, and use a squared notebook and draw it, you will see what type of curve this is. But we are not interested in this. Now let's write, what do I want? This. I want to take derivative of total revenue with respect to Q. So marginal revenue is equal to derivative of total revenue with respect to Q is the coefficient of Q, 10, minus 2Q. Okay, this is very simple calculus, derivative of an equation like this. But if this is problematic for you, if you have no calculus background, okay, whenever there is a linear equation with a negative slope, 10 minus Q, the number here should be double the slope here, okay? So you can just memorize in that way as well. So 10 minus 2Q will be my marginal revenue. So, okay, demand is this. Marginal revenue is this. Okay? How can we draw this on this graph? Very simple. Marginal revenue, like price, like costs, are represented on the vertical axis, right? So if quantity is 0, what is marginal revenue? 10. So it starts here, okay? Marginal revenue, like demand, starts here. If marginal revenue is 0, what is quantity? 2Q is equal to 10, Q is equal to 5. And I have a constant slope, which is minus 2, right? So the slope of marginal revenue curve is twice the slope of the, this is always true because it comes from this relationship, right? So I'm saying something that is always true. The slope of marginal revenue curve is twice the slope of the demand curve faced by the monopoly. So it is in absolute terms, you know, it is twice, so it is more vertical. And the vertical axis is the same as the demand curve. These are things that you would find to be true for any linear equation representing a demand curve for the monopoly. So again, this number always will fall in the middle of, right, half the number of where we have here the horizontal intercept. So always marginal revenue curve is twice steep as the demand curve. That's why we have 5 here and 10 here. Okay, this is my marginal revenue curve. If I want, I can even represent the negative side. So after this, once we know this shape, it is very easy to show the profit. But you will need, first, we want to find profit maximizing quantity, like in perfect competition, okay? What is profit maximizing quantity? To find profit maximizing quantity, we will need marginal cost curve, okay? Marginal cost curve, as I did when we are studying perfectly competitive markets, marginal cost curve, I give you a standard shape on these graphs. So I give you the shape of the curve. I might give you the equation, right? So marginal cost curves regularly look like this, okay? An upward sloping curve. So now I have marginal cost curve and marginal revenue curve, which is great because these are the two curves I need to maximize profit. How do I find profit maximizing point? Exactly the same we did in perfectly competitive markets. If marginal revenue is more than marginal cost, here, 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 you know, look at these quantities until here, marginal revenue is higher than marginal cost. To the right of this, marginal cost is higher than marginal revenue, which means profit is going down. Here, profit is increasing. Here, profit is going down. So this is where I want to stop. Okay? This quantity where marginal revenue is equal to marginal cost is the profit maximizing quantity. Okay? My profit maximizing rule didn't change. It is this. Okay? And this is profit maximizing quantity. What is the profit maximizing price for this monopoly? Now, we are making an assumption. Here, we are assuming this monopoly charges a single price for all the consumers. But you might see later throughout this course, sometimes monopolies charge different prices for the same good. This is called price differentiation. Now, for this simple case, we are assuming this is a single price monopoly. It will charge a single price for this good, right? So what is that price? Is this? Okay, this might be a price where marginal revenue is equal to marginal cost, right? In this example, if I give you a marginal cost equation, right? I can just make up a marginal cost equation. Okay, just an example. Or it can be Q plus 1. It doesn't matter. So marginal revenue let's make this Q plus 1. Okay, marginal cost is Q plus 1. Marginal revenue is 10 minus 2Q. Okay, 3Q is equal to 9. Q is equal to 3. Okay, this is the profit maximizing quantity. If I put 3 here, 2 times 3 is 6. 10 minus 6 is 4. Okay? Here I have 4. Okay, put 3 here. 3 plus 1 is 4. So here, the number I have here is 4. Is this the price? No, it is not. To find the price that this monopoly charges to make maximum profit, it is the price that people are willing to pay for this good. So you ask yourself this as the monopoly. If this is the quantity, okay, what is the quantity? 3. If this is the quantity that maximizes profit, to sell this quantity, okay, what is the highest price I can charge? What is the highest price I can charge? So from this quantity, go up to the demand curve and find this price. So what do? I put this quantity, 3, to the demand curve. Price is equal to 10 minus 3, which is 7. Okay? So the price we find is the price that is on the demand curve corresponding to this quantity. Okay? That is profit maximizing quantity. So what is the profit maximizing quantity? 3. What is the profit maximizing price? 7. What is total revenue? You can easily say 7 times 3, 21. 21 is the total revenue, this large rectangular, for this monopoly firm. Okay. One very important thing. At profit maximizing quantity, price is higher than marginal cost. This is always true for monopolies because of their downward sloping demand curve and downward sloping marginal revenue curve. At the point where they maximize profit, price is higher than marginal cost. Remember, for perfectly competitive markets, price was equal to marginal cost. That is why we said perfectly competitive markets are allocatively efficient. The price, how much value the society gives to this commodity, is the same as how much this commodity costs to the society, marginal cost. Okay, so in perfect competition, because price was equal to marginal cost, we called it allocatively efficient. But here, because price is higher than marginal cost, we cannot talk about allocative efficiency. Actually, when there is a monopoly, people are paying more than, okay, the cost to the society. They value this thing more. Actually, it would be better if the society produces it more, right? But we cannot do it here. So this is what we show. What is the total profit? To depict total profit, like always, we need average total cost curve, something we did with perfectly competitive firms. Now let me show you a positive profit-making monopoly. Okay. So how do we find profit? The same way we did in perfectly competitive markets. The difference between price and average total cost at this quantity gives me per unit profit times quantity. Nice, okay. This is the profit, okay? Because remember, the definition of profit, is price minus average total cost times quantity. So at this quantity, this is per unit profit. And we multiply it with quantity, we find total profit. This is a positive economic profit making monopoly. What happens in the long run? The answer, nothing. Because there are barriers to entry, unlike in perfect competition, there will be no way, no possibility for new firms entering. If they are able to enter, okay, if things change, the license that this firm has expires. Or maybe things are changing, right? And then more firms entering, like this firm, then we will not call it a monopoly. For this firm to be called a monopoly, pure monopoly, the barriers to entry should exist as before. So as they exist, this firm will continue to reap positive economic profits, nothing happens. Can a firm in a monopolistic structure make negative profit, meaning economic loss? Yes, theoretically it can. Let's say, okay, this is the firm that creates this crazy drink. Okay, I couldn't come up with a name, but this drink was popular, very popular, but something happened. There is a study about very disastrous effects of this drink on health. Okay, and this is a monopoly, but people now do not want to drink. The demand curve shifts left enormously, right? In such a case, you can depict theoretically, right, a demand curve that falls below the average total cost. Okay, it is possible. Like, it would be better if we draw it on a separate graph, but in a case, okay, let me summarize it this way. In a case where marginal revenue is equal to marginal cost, okay, we find profit maximizing quantity, and at that quantity, if price is lower than average total cost, okay, then that firm is making a loss. It is possible. What happens in the long run? The firm will exit. This can happen also when there is for some reason, the machine this firm uses becomes very expensive. Total cost curves shift up, right? That might be the case why this firm might be making a negative profit, meaning economic loss. In the long run, the firm exits because it doesn't make sense to make positive profit. In the short run, it might shut down or it might decide to produce by looking at average variable cost, which we talked about in perfect competition. The decision-making process is the same. Okay? Now, I want to draw one last thing about this. Let's draw a monopoly that makes zero economic profit. Okay. This is where marginal revenue intersects marginal cost. I don't need this anymore. This is profit maximizing quantity. This is profit maximizing price. So I want this firm I want to draw it in such a way it makes zero economic profit. At this point, the price at this quantity, profit maximizing quantity, should be equal to average total cost. If they are equal, right, remember this definition of profit. If these are equal, this will be zero. This will be making zero profit. Now, when this firm, it is possible in theory. What will happen in the long run? It depends. It is like this firm, in theory, will be indifferent between exiting or not exiting in the long run. Okay, just one crucial thing. Remember, in perfect competition, in the long run, all firms will be making zero economic profit. In monopoly, it doesn't have to be that way. They can be making positive economic profit. But there is one more thing. When in perfectly competitive markets, firms make zero economic profit, they are also producing, remember that graph, at the lowest possible cost. Okay? In the long run, firms in perfectly competitive markets are at equilibrium where price is equal to minimum average total cost. Minimum average total cost. Here, it is not minimum. It cannot be. Okay? So even when a monopoly is making zero economic profit, the price and the production cost, more importantly, the firm is producing at a cost higher than minimum average total cost, which means it is not productively efficient. So monopoly is neither allocatively efficient nor productively efficient. Can there be advantages to having monopolies? Yes. In certain sectors, we talked about this, there might be reasons that explain natural monopolies. There are such huge economies of scale, it makes sense that we have one firm. Sometimes having patents that creates a monopolistic market is good because in search of patents, firms will invest more in research and development, and they will innovate more and create new products. So these types of barriers sometimes can be beneficial. But from the perspective of consumer, a persistent monopoly means higher prices, right? And not allocatively efficient and not productively efficient outcome. Now, one last graph where we explicitly compare perfectly competitive market with monopoly. I think this place will be sufficient. So, remember perfect competition. This is market demand in perfect competition. This is market supply in perfect competition. Where they intersect, market quantity exchanged in market, market price, okay? Now, in perfect competition, let's say we have 100 firms here, okay? Just for simplicity, 100 firms, each small, each producing exactly the same thing. That is the definition of perfect competition. They are faced with a horizontal demand curve, perfectly elastic demand curve. This is their marginal cost, okay? So whatever profit they are making, I don't care about it right now. Come back here. This is perfectly competitive market outcome. Now, let's assume these 100 firms came together. They said, let's organize into a cartel, which would normally be illegal. But let's assume they get away with it, right? So they decided to be a monopoly. And they decided to act together so that they will increase their profits, right? So how do we show it on this graph? Now, once these 100 firms act like a single firm, okay, they have one man, okay, the manager, and they are now acting together. So they are not price taker anymore. They will be price makers because this demand curve, market demand curve, now I'm drawing the monopoly situation, will be the demand curve faced by the monopoly, okay? Demand curve faced by the monopoly. So they can vision that demand curve and they can also vision the marginal revenue curve. I mean, it doesn't matter the exact shape, but we know with a downward sloping demand curve, marginal revenue curve will be even steeper. So, a steeper marginal revenue curve. Unlike this one, okay, let me use. This was the marginal revenue curve for perfectly competitive firm. Now, what is the profit maximizing quantity for this monopoly? The same 100 firms now acting together. Okay, you might be asking, where is the marginal cost curve? Now, marginal cost curve on this graph for the monopoly will be equal to this curve. Why? Because for these 100 firms, remember, individual supply curves, we found them by looking at the marginal cost curve. The part of the marginal cost curve above the minimum average variable cost curve was the, now this was little s, okay, supply curve of the individual firm. So the market supply curve in a perfectly competitive market, we found them by horizontally summing individual supply curves. So the horizontal summing of individual supply curves, meaning individual marginal cost curves, gave me this. So this horizontal summation, when they act together, it also represents marginal cost curve of the total firm, of the monopoly. So this supply curve is the marginal cost curve of the monopoly, of the together 100 firms, right? So I have the marginal cost curve now. I have the marginal revenue curve now. When it is a monopoly, this is the profit maximizing quantity for monopoly. Now look, this was the perfect competition quantity. So once these 100 firms, they organize together and act like a monopoly, together they will produce less. Okay? Monopoly quantity is less than perfectly competitive market quantity. And what is the price they will charge? Sorry, I want to write here perfectly competitive price. I said market price, but this is perfectly competitive market price. Now, what is the price now? Go up. Monopoly price. So, monopoly price is higher than perfectly competitive price. Monopoly quantity is less than perfectly competitive quantity. Monopoly price is higher than perfectly competitive price. Why they are doing this? Because it is more profitable for them, okay, acting as a monopoly. So this is, you see how this is worse for consumers. Now let us show allocative efficiency here. Normally, if this was perfect competition, look here, this is something you already know. This triangle would be consumer surplus, and this triangle here would be producer surplus. This would be total surplus. We have shown it under perfectly competitive markets. Now, once we have monopoly, now you stop here. You stop here, you don't produce more than this. So this, okay, wait. This is the price monopoly is charging. The difference between the demand curve and the price will give us consumer surplus at monopoly, under monopoly, consumer surplus. And remember the definition of producer surplus. Price charged, I will do it this way, and supply curve. The difference between price, I stop here, price charged and the supply curve. So this, what is this? Actually this triangle plus rectangular here, right, will be producer surplus in monopoly, consumer surplus in monopoly, producer surplus in monopoly. So producer surplus is larger, consumer surplus is smaller under monopoly. And what happened to this area? This will be called deadweight loss. It is gone, right? This is the reason why we say there is no another way of saying why there is no allocative efficiency in a monopolistic market structure. We lost this. And also there is a transfer of surplus from consumers to producers. So these are the results of monopolies, and this is where we will stop.